We're going to start here with chapter 10. In chapter 10, we'll be finding areas of lots of different shapes and stuff. So hopefully you'll like this one. Today we just kind of want to focus on parallelograms and triangles. Some of this is probably familiar to you. So a base of a parallelogram is any side. An altitude is a segment that's perpendicular to the line containing a base. Height is the length of the altitude. So I've got some pictures down here. So I mean, we're kind of used to thinking about a parallelogram being slanted, but technically a rectangle is still a parallelogram, if you remember back from chapter 6. So here, this right here would be a base. And then if I draw this line in there, so I make a segment and I make it perpendicular to that base, this right here is my altitude, and then the height is the length of that. Likewise, I can do it here. Now, if it's that, I don't know why I'm using dotted and I didn't over there, just because I am. All right, so again, if I draw a segment perpendicular to the base, this right there is the altitude. So again, there's the height. Just realize that with these parallelograms, sometimes they draw it on the outside. So this is the height. This part's still the base though, okay? All right, so the area of the rectangle. You should know this one already. It's just the product of its base and height. So if I draw my little rectangle, the height's the same thing as the altitude, because if I have a rectangle, remember that's that perpendicular right there, right? So the area is equal to the base times the height. Don't forget, when you're finding the area, their units are squared units, okay? The area of a parallelogram. So a parallelogram is also the product of a base and the corresponding height. So draw it. So basically what this is saying here, so there's my height, that the area, again, is just base times height. Now, if you think about it, pretend, you don't need to do this to your paper, just look at my paper. So let's just say I draw this straight up and down line right here. So this piece right here is a triangle, right? And let's say I took that triangle and I put it over here. So now, what shape do I have there? It's just a rectangle, like this one right here. So that's why the area is base times height for both the rectangle and the parallelogram, because the parallelogram, I can basically turn it into a rectangle if I just chop off that triangle and put it on the other side. All right. You don't need to think about doing that, though. You just do it when you don't need to worry about it. That's just my explanation for why they're the same thing. Again, you still want those squared units. So here, when it says find the area of the parallelogram, all right. So the parallelogram, we need a base and a height. So if you can see here, this base, right, this is a base, and this is a base right here. And this right here is a height. But the question is, I have two bases, and I only have one height. So which base does that height belong to? So this height right here belongs to this base because it's perpendicular to this one. There would be another height that could belong to this side, but it would have to be perpendicular like to this one, and we don't know what that height is right now. So that's why when I find the area here, I am only going to use the 2 and the 3.5. Like I said, there's this other height right here, but that's not really included right now. I multiply those together, I get 7. Remember, the units are centimeters squared. Okay, this one, though, is a problem in which I want to pay attention to what's going on here. So, if you look here, this side right here is 9.4. But this height goes with the 9.4 because there's the perpendicular line right there. Okay? Then Ooh, gold pen, exciting. This right here is, oh no, I have never used it before, so it has a little thingy bar on the pen. All right, this is 13. That one goes with this number right here, okay? So these ones go together. This one goes with whatever that one is. So it says find the missing dimensions. So that question mark there, right there is that missing dimension. So what I'm going to do here is I'm going to find the area with the dimensions that I have. So 13 times 9, so I get 117 inches squared. So I know that this area of this whole thing right here is 117 inches squared. It doesn't matter like which way I'm looking at it, but whenever I multiply the base times the height, I have to get that answer. So the other way to look at it, so again, remember, area is equal to base times the height. So I know the answer is 117. This base right here is 9.4. This is the height that I didn't know. So now I can just take this and I can solve. So I can do 117 divided by 9.4 and I get 12.4. This would be just be inches. It's not, because I'm not finding an area there, so it's not squared units. So DE is equal to 12.4 inches, because that's what that H is, okay? All right. Next up is a triangle. So the base of a triangle is any side. So you can make any side be the base of the triangle. The height is the length of the altitude to the line containing the base. So again, if this is the base, this right here is an altitude, because remember what we said on the first page, an altitude is a segment perpendicular to the line containing the base. So there's that height right there, okay? Then, so the area of a triangle. So before we talk about the formula for the area of a triangle, let's just think here for a second. What would happen here if I take this triangle and I kind of go like this? So this line, I made these lines parallel. And then this line right here, so I made these lines right here parallel. What shape do I have? That's right, I have a parallelogram. This one is very hard to see, but it kind of looks really cool on my paper. So I have a parallelogram. So therefore, the triangle is just half of that parallelogram. So that's how we get the formula for the area of a triangle. So the area of a triangle is half the product of its base and the corresponding height. So again, if you have that triangle, so the area is equal to 1/2 the base times the height. Now remember, triangles can be kind of weird. So maybe I have like a weird obtuse triangle. It looks like this. And this is the base. Remember that height always has to be a perpendicular segment to the base, all right? So just remember those triangles can be kind of weird. All right, this one right here, finding the area of an irregular figure. All right, when you're finding the area of an irregular figure, you basically want to find the area of the parts and then add them together. So take a second right now, pause the video, and see if you can figure out what the answer is, and then unpause it and check with my answer. So I'm going to find the area of the triangle there. I'm going to find the area of the square part. And then I'm going to add them all up. And remember, it's inches squared. Okay? All right, let's look at a couple of these homework problems. Let's see here. Some of them are pretty straightforward for sure. Again, these are the ones that kids kind of have trouble with, finding that missing dimension there. So let's look at number 13. So in number 13, again, just kind of like what we did in the notes there. the 18 and the 12 are matched up together because they form that perpendicular relationship there. And then I know it looks like it's perpendicular to here, but that side is also 13 because it is a parallelogram. So the H and the 13 go together. So for number 13, I know that again, the 12 and the 18 go together. So when I find 12 times 18, I get an area of 216. They didn't give me units there, so if you could say sometimes people might write like unit squared, or they just write u squared if they don't give you units, so you could do that if you wanted to. Then I know that that's the answer to the area. So, but the other way is 13 times the height I don't know. So when I solve for that height, I do 216 divided by 13, I get 16.6. This is 0.6. And the units on that, again, there's no units there, so I just could say U or units or whatever you wanted to say there. Okay. Let's see here. The only other one, well, let's look at number 31. It says, suppose the height of a triangle is tripled. How does this affect the area of the triangle? So if my formula for the area of a triangle, so this is 31, area equals 1/2 base times height. So what it's saying I'm doing here is that I am tripling the height. So it's like I have 3h. So this is all just multiplication. So if I bring the 3 out front, this is just the formula for the area of a triangle right there. So basically, if I triple the height, then I've just tripled the area of the triangle, okay? So when I triple one dimension, I've just tripled the area of the triangle, okay? All right, then let's look at 35. So with number 35, it asks you to graph the lines. So this one is a regular line. So you have an intercept of -2. The slope is 3/4. This one you have y equals -2, and you have x equals 4. So when I plot those things right there, here's my, this is my x, y ordered pair. That's my coordinate plane right there. The black lines are my x and my y. There's the -2 intercept. I go up 3/4. There's the slope. This line right here is x equals 4. This line right here is y equals 2. So then when I find the area of the triangle, the base is just 1, 2, 3, 4 units. The height is 1, 2, 3 units. So the area of the triangle is just 1/2 the base times the height. Okay? Alrighty.